Good day, sir. How are you? I am Kadichan Kiniti Madrio. So now I'm gonna discuss the radar control function or the radar function. So first, we have the radar X-band. So X-band radar frequency range between 9,300 and 9,500 megahertz, and a wavelength of 3 centimeter. The next is the S-band radar. So S-band radar frequency range between 2,900 to 3,100 megahertz, and the wavelength of 10 centimeter. So magkaiba sila. So X-band is widely used because of the ability to utilize smaller antennas that fit on most boats and to provide better target resolution. S-band radars are often used for specialized applications such as seeing through heavy weather or precipitation and for long-range bird detection. S-band antennas are larger. The next is ABL, or the acronym of Electronic Bearing Line. So ABL, it is used to determine the bearing from your present location to a specific target. Use the ABL function to bisect the target and see its bearing, the ABL readout display. The next is brilliance. So the brilliance control on the analog radar, old style, so controls the brightness of the rotating trace, and it will also affect the brightness of the display echo. So it needs to be adjusted so that the trace itself is just visible to give a good contrast between echo and background. So ang purpose nitong brilliance is ito yung nagbibigay ng liwanag sa ating radar. And the next is ECC control. The ECC control reduces the amplification of the echoes at short range, where clutter is the greatest, and progressively increase amplification as the range increases. So amplification will be normal at those ranges where there is no C clutter. And AC rain control. The rain clutter control will reduce the interference on the screen due to the rain and increase the chance of seeing targets within rain showers. So here the gain control may appear to function like the brilliance control in that it makes the picture brighter or darker, but is completely different. So it is vital not to confuse the two. Gain affects the receiver and not the display as the brilliance does. So turning up the gain increases the amplification of the incoming signal, making weak echoes look stronger, but confusing the display with background speckle or noise. So similar to the background cracking of an ordinary radio. Turning down the gain will reduce the sensitive of the receiver and reduce the noise. But care must be taken not to be overdosed weak, though distance echo can't be lost. So next is range. So the range control regulates the range as which the sets operates by changing the size or scale of the areas on the display. So note, it is considered good watchkeeping practice to weigh the range monitor so as to get the best use of the radar detection capability. Next, VRM. The VRM, or the variable range maker, measure the range to target. To measure range, press the key to display the VRM. It appears as a dashed circle. Adjust the VRM so that it touches the inner edge of the target. tuning or tune. The tuning control can be compared to the tuning control of an ordinary radio. It tunes the receiver to the frequency of the transmitter. Poor tuning adjustment may not be easily recognized on the screen. Tuning slightly out will eliminate some very weak echoes, but it still produces a clear picture of the stronger ones. Hence, the importance of the frequent fine-tuning of the set. Not all sets have a tuning control. Okay, so the next is course up. So here we have the example. We have the radar display. So course, waypoint go to equals direction equals up. So sa ating radar, makikita natin, example, we have course may go by 0.78 degrees. So 0.78 degrees is nasa taas. Makikita natin sa ating display. So ito yung example ng course up. Dito yung 0.78 degrees. Ang 00, dito yung north. So, that is the example of course up. The next is head up. So, example, bow equals direction equals up. So, example, we have the course. Again, 0.78 degrees. So, ang ating barko is makikita natin sa radar, ang barko natin is nakatutok sa taas. So, ang bow is makikita natin sa ating radar display is nasa up. So, that is the example of head up. The next is north up. So, think compass north, east, southwest. So, same, we have the course of 0.78 degrees. Ito, kikita natin, yan. So, ang north is dito, 00, dito yung east, dito yung south, ito yung west. So, walang mababago sa ating GPS. So, that is the example of north up. Okay, the next is the relative motion. So, the relative motion display portrays to the motion of a target relative to the motion of the observing ship. So, here we have the example, the radar plotting sheet. So, the red is our own ship and target vessel is the yellow. So, for collision avoidance, relative motion display is preferred for calculating a closest point of approach. So, we say the target vessel is pointing to our own ship. So, the closest point of approach is 0. So, in this situation, we need to take action to avoid the collision. So, that is the example of the relative motion. Okay, the next is true motion. To show the true motion, in a true motion display, the center of the picture moves across the screen in the time with the actual movement of the vessel. So, true motion is the preferred choice of many operator for the piloted operation, as you can watch your vessel progress on the display in the same manner as you would with a GPS plotter. So here we have the example. We have the radar plotting sheet. So we see the motion of the vessel. So the next. So we see our own shape is movement. So that is the example of true motion. Okay, and that's all, sir. Stay safe. So thank you.